Hi, in this video, we're going to continue our lesson about linear inequalities. In this part of the video, I will show you how to solve uh, linear inequalities. Now, this time, we're going to find the solution set. Okay, why set? Because most of the time, um, the values for x or y or any variable involved will be infinitely many. So that's why it's important that we collect all those values in a set. So that's why we require that our solution be uh, contained in a set. So we will solve number 1. We're going to find the solution set. 2x minus 1 is greater than 3x minus 2. Now, our objective here is actually we're going to get the value of x such that our inequality will be true. So, what are those values that we're going to put here in our x so that our inequality will be true? So, that is our objective. We're going to find those values. Now, to do that, we have to make sure that our x's, expressions involving our x, will be transferred to usually to the left side of the inequality, and our constants will be on the right side, just like how we solve equalities. Okay, so we solve this one, and what we will do here is we're going to transfer or we're going to remove this minus 1, and then we're going to uh, uh, remove this one. Of course, it will be transferred to the other side of the inequality, as well as for 3x. So we're going to remove this one in the right side and then transfer it to the other side. Now, to do that, we will apply the addition property of equality. Okay, just remember the addition property. We're going to add the same number on both sides of the inequality, and the sign of inequality will not change. Now, so of course we're going to remove this one. To do that, we are going to add positive 1 to both sides of the inequality. Okay, so we're applying the addition property of inequality. So that's 2x minus 1. So I'm going to add 1 both sides of the inequality. So that's plus 1. So this will become 0. So you're left with 2x. So 2x plus 0. So do not write plus 0 anymore. So you have 3x, negative 2 plus 1, that's negative 1. And then continue, we're going to transfer this one to the other side. Now to do that, we're going to apply the subtraction property of inequality. So we're going to subtract both sides by 3x. So 2x minus 3x is greater than 3x minus 1 minus 3x. So simplifying the left side of the inequality, this becomes negative 1x or negative x. It's greater than. This will become 3x minus 3x, that's 0. So you're left with negative 1. And then the objective here is to get or to know the value of x, not negative. So we are going to remove negative. So actually this one is negative 1. So we're going to remove negative 1. To do that, we're going to divide both sides, just like equality. So we will apply the division property of equality, and particularly we're going to apply 2i, because we're going to divide both sides by a negative number. So remember, we're going to divide both sides by a negative number, that is negative 1, right? So since this negative 1, so if you're going to divide both sides by a negative number, this one will become less than. Okay, less than negative 1 over negative 1. So, of course, negative 1 divided by negative 1, so cancel out. So, you're left with x will be less than negative 1 divided by negative 1 is 1. So, our solution, so the values of x are those that are less than 1. So, there are many values for possible values of x. So, uh, it can be 0.99, 999, 0.5, 0, negative 1, and so on and so forth. So there are many values of x that you can find as a solution of our inequality. So there are many. Now, we're going to put this one in a set. So the solution set will be a set of all x such that x will be less than 1. So which means to say that this set contains infinitely many numbers which are actually less than 1. So you can think of x as 0.99. Again, it can be 0, it can be negative 1, and so on and so forth, as long as it is less than 1. So meaning there are many values of x that you can substitute here to become, so that this inequality now will become true. So let's try some values, okay? Although um, we cannot try every value of x, but let's try some values, okay? So since x is less than 1, we can choose any number less than 1. Let's say, to make it simple, to make our computation simple, we let x be uh, less than 1. So I think we can try 0 because x is less than 1. Now let's substitute in our inequality, our original inequality. So that is 2 times 0 minus 1. Is it really less than 3 times 0 minus 2? So this one is 0 minus 1. Is it less than 0 minus 2? So this one is negative 1. Less than negative, greater than, I'm sorry, greater than negative 2. So indeed, the left side is greater than the right side. So our inequality is true when we substitute 0. We only tried 0, but you can try any values that is less than 1. So you can try negative 1, still our inequality will be true. Okay, so meaning the left will be greater than the right. So in this case, yes, if our x is 0, and so on and so forth. You can try many values. Again, there are infinitely many values. That's why we're putting this one, collecting all the x's and putting them in a set. So this is the solution set. Okay. Before we go to example number 2, take note of this. Transposition also works for solving linear inequalities. Do you still remember the transposition? Right. So instead of adding or subtracting both sides of the inequality, all you have to do to make our solutions less complicated, so just simply in transposition, you already knew that if you're going to transfer this one to the other side of our inequality, the sign will change. So from negative, this becomes positive 1. Okay, so let's try an alternative solution. Okay, using transposition, can we still get the answer, which is x is less than 1? Okay, so 2x minus 1 is greater than 3x minus 2. So transposition still works here, okay? So instead of adding 1 both sides or subtracting 1 both sides, use the transposition. So transposition, if you're going to transfer this one to the other side of the inequality, the operation or sign will change. So from negative becomes positive. All right. So now this becomes greater than 3x minus 2 plus 1. And similarly, if you're going to transfer this one to the other side, so since this is positive, so this will become minus 3x, okay? So this becomes 2x minus 3x greater than negative 2 plus 1. So this becomes negative 1x to the negative 1. This negative 1x is just negative x, right? And then divide both sides by negative 1 to remove negative in our x because we don't need negative. So negative x is, if you're going to divide by a negative number, so the sign will change, or the inequality sign will change. Negative 1 over negative 1, that is, cancel this out, x is less than positive 1. Still, we got our answer. So still the same, right? So transposition still works in inequalities, linear inequalities. Even in uh, other types of inequalities, okay, even quadratic, so transposition still works. So I suggest that you are going to use transposition to make our solutions less complicated. Okay, so that is number 1. Now let's proceed to number 2. Okay, so I think we're out of space. Let's make up the space that we have. Okay, so let's show number 2. So for number 2, we have 4x minus 5 less than or equal to 7x minus 2. We're going to get the solution set, okay? Remember, we're going to get the solution set. So, transfer using transposition, that becomes negative 7x less than or equal to negative 2 plus 5. Then negative 3x less than, so this becomes 3. Now we're going to remove negative 3 by dividing both sides by negative 3. And remember, if you're going to divide negative number, this one will change. So this becomes greater or equal to. So negative 3x, that will become greater than or equal to 3 because we're going to divide both sides by a negative number. So that's x greater than or equal to negative 1. So this is our so these are our values of x. X should be greater than or equal to negative 1. Okay, remember we have equal to, so x can also be negative 1. So any value that is greater than negative 1 or equal to negative 1. So what are those values? Negative 1, greater than negative 1, so 0, even negative 0.99, even 1, 1.5, and so on and so forth. Any number that is greater than or equal to negative 1 are the possible values, is a possible value of our x. So our solution set here is, the solution set is the set of all x such that, of course, x is a real number, such that x is greater than or equal to negative 1. So that is our solution set. Of course, there are many possible values of x. So again, x can be any number that is greater than or equal to negative 1. So there are many values of x that you can think of, that you can substitute in our inequality. Now again, as similar to example number 1, you can try any value. Okay? So let's try. Okay, let's try any value that is greater than or equal to negative 1. So let's say I will choose x to be 1. Okay? Okay, so now let's substitute this one in our original inequality. That's 4 times 1 minus 5 less than or equal to 7. Okay, we will substitute now. So this becomes 1, then 2. So let's see if the left is equal to the right. So 4 minus 5, 7. So that becomes 5 now. So this is negative 1, which is less than or equal to 5. Yeah, it's true that negative 1 is less than 5. So x 1 is can be a value of x. You can try many values. In this case, there are infinitely many values of x that we can try. Unlike equalities, um, linear equalities, we only have one value of x. This time, we have many values of x, or sometimes there are no values of x that can satisfy our inequality. There are cases. Okay, so you can try number 3 as your practice exercise, and then I think we can try number 4, and then we will use distributive property. So I will write again the given. So that is for number 4. You can try number 3 as your exercise. That's x minus 3 greater than or equal to 1 over 3, then 7x minus 2. Okay, so let's get the solution set. So in this case, there are many ways to solve this one. You can try distributive, or you can do this one. Since this is multiplication, okay, you can multiply both sides by the reciprocal of 1/3, which is 3, so that this will be cancelled out and you are left with this expression. You can still do that, okay? So I think that will be the most efficient way than distributive. Okay, so now what we will do here is we're going to multiply both sides by the reciprocal of 1/3, which is 3. Remember, we're multiplying a positive number, which is 3, all right? So if you multiply a positive number, then our inequality will not change. Remember that one? That's property number, or theorem number 17.2.3, part A, or part I, all right? So meaning the inequality will not change, okay? You're going to multiply a positive number. So that we're going to apply here. So now we have this one. So x minus 3, still the inequality sign will not change, because we're going to multiply both sides by 3, which is reciprocal of 1/3. And so we're going to simplify, and this becomes, okay, so it will be cancelled out. So 1/3 times 3, you can cancel it out. You're left with 1. 1 times this one, so the answer is this one. So you're left with 7x minus 2. And this one we have 3x minus 3. 3 times the quantity of x minus 3. Then you can use the distributive to remove the parenthesis. So because 3x minus 9 greater than or equal to 7x minus 2. Just like before, we're going to use the transposition. There are many ways. 3x minus 7x, then negative 2 plus 9. Okay? Then solving for x, we have negative 4x greater than or equal to positive 7. So now we're going to remove negative 4 by dividing negative 4 both sides. So since you're going to divide negative number to both sides of the inequality sign will change from greater than or equal to, it becomes less than or equal to 7. So x is less than or equal to 7 over negative 4, or you can have negative 7 over 4. Negative 7 over 4, that is, can divide that one. So 7 divided by 4 in decimal, that's 1.75, or negative 1.75. Anyway, we have our solution set now. The solution set will be all x that is a real number such that x is less than or equal to negative 7 over 4. Again, there are many values that you can think of that is less than or equal to negative 7 over 4. This one is negative 1.75 if you're going to convert to decimal. So find those numbers. You can find many numbers that is less than or equal to negative 1.75. So one of which is negative 2, negative 3, negative 3.5, and so on and so forth. Infinitely many values. So that's the solution set. Again, you can try any values of x in our original inequality. So all those values of x that belongs to this set will satisfy our original equation inequality. So that would be all for inequality, and thank you very much and have a nice day.